Hello, in this video I'm going to be talking about rotation and specifically looking at the parallel axis theorem. But before I get into that, I would like to note that I strongly suggest that you go watch the previous two videos before this one as I discuss other rotation concepts, key concepts such as rotational kinematics, angular momentum, moment of inertia, and torque in those previous videos in depth. Also, those two problems relate to the problem I will be discussing in this video. So make sure you go ahead and watch videos number 17 and number 18. So getting right into the parallel axis theorem, essentially the parallel axis theorem is a way of finding the moment of inertia around any parallel axis. So the formula for that, for the parallel axis theorem, is that the inertia of the one axis, like that, is equal to inertia of the axis prime plus m mass times distance squared. So I am going to go, now that we've got that covered, I'm going to go ahead and read the problem. I have drawn the figure here and stated the givens right here to refer to in this video. So a solid disk of mass m and radius r is freely rotating horizontally in a counterclockwise direction with angular speed w about a vertical axis through its center with negligible friction. The rotational inertia of the disk is mr squared divided by 2. A second identical disk is at rest and suspended above the first disk with the centers of the two disks aligned as shown in the figure above. There is no contact between the disks. The second disk is dropped onto the first disk, and after a short time, they rotate counterclockwise with the same angular speed. So now I'm going to go ahead and read the question specific to problem number 19. So the two disks are now shifted so that the axis of rotation goes through a point on the edge of the disks. The rotational inertia of the two disk system is now blank. So we're going to go ahead and refer to this formula right here. We know that the inertia of the two disks combined is going to be equal to the inertia of the sum of the two. So essentially the inertia of L prime is going to be equal to 2 times mr squared divided by 2, which simplifies to mr squared. And then the distance squared is just the radius, so r squared. So we're going to go ahead and plug that into our parallel axis theorem formula. So we can say that the moment of inertia is going to be mr squared, which I took from here, which we just calculated, plus m times our distance is just r, so times r, times mr squared. And, the distance is 2 times the radius, so that this is actually going to be 2 times, since it's two disks, it's 2 times mr squared, and you add that together to get 3 mr squared, and you check for any, you check the exam to see if any of these match up to the answer choices, and we find that this matches to option B. So we can conclude that option B will be the correct answer for this problem. Thank you.